Watch this. This is a full-stack AI chatbot app. Postgres, Redis, file uploads, streaming responses from Claude, all deployed to your production AWS account with a single command. And today I'm going to show you exactly how that works. I took Vercel's official AI chatbot template. It's one of the most polished open source chat UIs out there. It has multimodal support, file uploads, message history, and resumable streams. But it's built entirely around Vercel's ecosystem. Vercel Postgres, Vercel Blob storage, Vercel AI Gateway. If you want this to run on your own AWS account, you can't, not without replacing every single service. So that's what I did. In this video, I'm going to show you exactly how to deploy apps like this to AWS using SST, so you can apply this practice to your own projects. But let me show you the final result first. Everything you just saw, the AI streaming responses, the file uploads, the model discovery, it's all running on AWS. Postgres on RDS, Redis on ElastiCache, file uploads on S3, AI through Bedrock, and the actual Next.js app itself deployed as a Lambda function. Let's break down how. For infrastructure, we use SST. It's an infrastructure as a code framework that allows you to define all your cloud resources in TypeScript. So there is no need for YAML files or CloudFormation templates, just pure TypeScript code. So let's open the sst.config.ts file in the root of the project. At the top, we have the basics like project name, the AWS provider, and which stages we want to protect so you don't accidentally nuke your production data. The important part here is the run method. Here we define everything that gets deployed. Let me walk you through each resource. First, we need a VPC, a virtual private cloud. This is a private network where our database and cache will live. We set up a VPC with a Bastion host. This is a small EC2 instance that allows us to connect to the private network through SSH, and it's helpful, for example, to run migrations on our databases or debug our services. We also use an EC2 NAT gateway instead of using an AWS managed gateway because it's significantly cheaper and does the same thing. We need those NAT gateways because it allows our services to connect to the internet outside our private network. Next, the database. We use Postgres component from SST to deploy Postgres instance on RDS. We specify the VPC it lives in, database name, instance type, and of course the Postgres version. Now here's where SST gets interesting. See this dev block? When you run SST dev command, SST won't spin up the actual RDS instance. It takes minutes and it costs money. Instead, it points to the whatever you specified in this dev block. So in our case, we are going to use our local Postgres instance deployed to our Docker container. We have a Docker compose file that spins up both Postgres and Redis locally. So SST dev command is going to use those containers instead. For Redis, we use ElastiCache. We need Redis for one specific thing, resumable streams. When a user sends a message and the AI is streaming a response, we need that publisher and subscriber, so if the connection drops, the client can reconnect and pick up where it left off. Redis handles that. Same pattern here, the dev block points to our local Redis instance. File storage is straightforward. One bucket for user uploads, private by default. When a user drops a file in the chat, it goes right here. We also define secrets through SST. For example, auth secret for next auth. SST encrypts those secrets and makes them available at runtime in your code, so there is no need for .env files. And finally, the app itself. SST's next component uses OpenNext to build our next application and deploy it using Lambda functions with streaming support. We configure the domain and configure redirects here, and the most crucial part, we link our resources here. This is the key concept in SST. It's called resource linking. When you link a resource to your app, SST automatically makes these resources credentials available in your code. So there is no need to manage those connection details using environment variables. Let me show you what that looks like in practice. Let's look at how we connect to Postgres. Instead of reading a Postgres URL environment variable, which the official Vercel template does, we use resource from SST, and then we access the database credentials directly. SST knows which database you linked, and it injects the right values in runtime. Whether you're in dev mode talking to your local Docker container, or in production talking to your actual RDS instance in the cloud. We pass this to Drizzle ORM to set up a connection. One thing to note, we only enable SSL in production. And same pattern we use for secrets. Instead of reading process.env.auth secret, we just import resource and use it directly. For file uploads, the original template uses Vercel/Blob package, but we replaced it with AWS S3 SDK. The upload route now uses put object command to write to the linked bucket. The bucket name comes from resource.uploads.name, again, automatically resolved by SST. For Redis, we use IO Redis package and use the same linked resource credentials from the resource object. One important detail, Redis publisher and subscriber needs two separate connections for publishing and subscribing, so you can't use one connection for both. So we create two. And like the database, we enable TLS only in production. The original template uses Vercel AI Gateway to proxy requests to different AI providers, so we replace that with AWS Bedrock SDK. We swap out Gateway package to AI SDK Amazon Bedrock and create our Bedrock provider pointed at our region. The default model is Claude Sonnet, and specifically its cross-region inference profile, which means that AWS is going to route our requests to available capacity across regions. For the Lambda to call Bedrock, we need specific IAM permissions, so we need to go to sst.config file and add them. Here is something that wasn't in the original template. Instead of hardcoding a list of available models, we created an API route that is going to query Bedrock at runtime. It lists all cross-region inference profiles and on-demand foundation models, and also it filters out non-chat models like embedding models or image generation models and returns the list of available models. And now let me show you how the development workflow works. We have a simple Docker Compose file with Postgres and Redis. You need to run Docker Compose app and then SST dev commands. SST's dev mode runs your Next.js app locally with all the resource links resolved to your Docker containers. You write your code against the same resource.database.host API and it will work locally and in the actual production environment the same. When you're ready to deploy, just run SST deploy command and it will provision all the necessary AWS resources in the cloud. So let's actually deploy. SST provisions VPC, our Postgres instance, Redis instance, S3 bucket, and the actual Next.js app itself. Everything from one single TypeScript config file. And there it is, a full stack AI chatbot app deployed to your own AWS account. If you want to try this yourself, the full source code is available in the description. So go there and clone it, set up your AWS credentials, and run SST deploy.